Okay, this is a lesson 11.3 where we're talking about reflections. A reflection, also known as a flip, is a transformation in which a figure is reflected in a line. That line is called the line of reflection. A reflection creates a mirror image of the original figure. So weird way to word that, it is reflected in a line. It's not reflected across a line. It's reflected in the line, just like you're reflected in the mirror. Example 1, identifying a reflection. Tell whether the blue figure is a reflection of the red figure. So for A, the red figure can be flipped to form the blue figure. So yes, it is a reflection. Example B, no, that is not a reflection. That's more of just a slide there, so not a reflection. The key idea here is reflections in the coordinate plane. So to reflect a figure in the x-axis, take the opposite of the y-coordinate. The x-coordinate stays the same. Remember, when you're reflecting in the x-axis, it's going either up or down over the y-axis. To reflect a figure in the y-axis, take the opposite of the x-coordinate, and the y-coordinate will stay the same. That's like going from the red figure to the green, or from the green to the red. That's going reflecting in the y-axis. In algebra, or just looking at it number-wise, reflection in x-axis, the x-coordinate you see stays the same, and the y goes from y to negative y, meaning the opposite of y. Reflection in the y-axis, it's the y that stays the same, and this time it goes from x to negative x, which just means the opposite of x. In a reflection, the original figure and its image are congruent, but they are mirror images of each other, but they are still congruent. For example 2 here, reflecting a figure in the x-axis. The vertices of a triangle, and this is the red triangle, A is negative 1, 1, B is negative 1, 3, and C is 6, 3. So they drew that red triangle in there. Its reflection in the x-axis is the blue triangle down below. Notice the x-coordinates stay the same. A was on negative 1 for the x-coordinate, and it's still on negative 1. But it went from the y-coordinate 1 down to negative 1. We take the opposite of the y-coordinate. Another way to do this is just it was one space away from the x-axis, so its reflection will also be one space away, but on the other side of the x-axis. Same with B, and same with C. C was 3 spaces above the x-axis, and now it's 3 spaces below the x-axis. Once you put in A prime, B prime, and C prime, just draw in your new triangle. And when you just look at them, they should look like mirror images of each other. And remember, they are congruent. In example 3, reflecting a figure in the y-axis. So now they drew in the red quadrilateral with the coordinates shown, and we have to find the blue, or the blue quadrilateral, the reflection. So they're doing it this time just by taking the coordinates, and because we're going across or in the y-axis, the y number stays the same, but we're getting the opposite of the x. So if you look for the coordinates of P, it was negative 2, 5. Well, the 5 is going to stay the same. But instead of negative 2, we take the opposite of negative 2, which would just be positive 2. So P prime is 2, 5. Q went from negative 1 to the opposite of the x, so it's going to be 1, and the y stays the same, negative 1. For R, negative 4, 2 became 4, 2 for R prime, and S went from negative 4, 4 to S prime, 4, 4. Now you plot all 4 of those points, you draw in your quadrilateral, and it should be a mirror image of the original. but it's reflected in the y-axis, so it's going off to the side.